Okay, hello everyone. Let's go ahead and begin. Some updates on various stuff that's going on. We're trying to get everything caught up with grading, so we have all the studio grades, of course. Those are in the process of being punched in, and the first assignment is almost done being graded. I checked right before I came to class, and there were like maybe 10 or 15 that hadn't been graded yet. So that means most of you have already got a grade for assignment 1. If you haven't got a grade for assignment 1, sit tight. We're almost done. I'm hoping to have those finished by the end of the day tomorrow. That's my goal. You'll get the rubric given back to you in your repository, and then once we have all the grades done, it'll also show up on Canvas. So that's what we've been working on the last few days. The due date for assignment 2 is coming up. It's on Thursday, so assignment 2 is due on Thursday. Are there any questions I can answer about that assignment right now before we do some other stuff? Anybody have any questions about assignment 2? Yeah. Yeah. Sure, if you want to, you can push. Yeah, you can push before you're done, and if we don't see any more pushes, then that's what'll get graded, right?
Okay, so like your last push is like what will be graded, and then
that's correct.
Your late coupon to be calculated
based on your last push. Yeah, based on the timestamp. Yep, that's right. It's actually your commit, not the push. To be completely 100% clear, it's based on your last commit. Yeah. That is always helpful if you want to use that as your commit message, to put in a little message saying this is the one I want you to grade. But if you don't do that, again, we're going to do it based on your last commit, whatever that happens to be. So, yeah. What's up?
So the main activity, it seems like, can be directed to for multiple different activities in the app, but it's also what started on the start of the app. And so we don't want to really assume that there's an intent there, for example, but I'm not sure we've learned how to because activities work like stack frames, is that right? Where they stack on top of each other, and when you close out of one, it just kind of brings back whatever.
There definitely is a stack involved that keeps track of your history in terms of where you've been, yeah.
But that doesn't seem like a guaranteed way to get back to main activity from anywhere, so I'm just confused about how we handle that.
I'm not entirely sure I understand what you're asking about. Like, are you asking about when you first start up the app, or are you asking about...
Well, main activity gets started when you first start up the app.
Uh-huh.
You can also go back to it from other activities.
Yeah.
But it seems like we don't want to assume that there's an intent coming in.
Okay.
I can also ask in TA hours around.
No, I think you brought up a good point, right? If you start the app for the first time, there may not be an intent there. That's correct. If you try to access the intent, what's it going to be? I know some people run into this.
Exception.
I don't think it will give you an exception necessarily. If it does give you an exception, what exception are you seeing?
Null.
No, it's going to give you back null for the intent. You can always ask it if it's null or not. And then just don't use it if it is, right? As one possible solution. So just checking to see if something's null. Never a bad idea. This is another case where that might come in handy.
All right, thank you.
Yeah, of course. Any other questions about the assignment before we hop in? So today the topic is databases. And I was going to show you a demo of what we're going to build today, but of course my emulator crashed. So we'll just have to kind of wait and see at the end what it looks like. I do think that we'll have time to finish up this app today. And so I want to remind you again, and this won't be the last time. I know it's not the first time. It won't be the last time, of the structure of this app and basically all of the apps that I'm hoping you will build over the course of this semester are going to follow the model, view model structure, right? So it's always important to understand what that structure is and where the various parts of that structure are. Sometimes easier, sometimes more difficult. The view, I think, is probably the easiest one, right? That's what the user sees. That's all the activities, fragments. That's all part of the view. The layouts, it's all part of the view. The model and the view model, where things get a little bit trickier. But in this case, since we're working with a database, the model is going to include code that interacts with a database. Now, on a phone, The database that's often used is one that's called SQLite. It's not the only one, but it's a common one that's often used. So it's not necessarily a full-fledged database. If you're used to using like a MySQL database or an Oracle database, maybe you've come across those in other situations in other classes. It's not really the same thing. SQLite database, as its name implies, is intended to be very lightweight database. Consider you're on a mobile phone, so the more lightweight you can make it, it strips away a lot of the extra bells and whistles, right? It's not going to do a lot of the fancy database stuff that you can do with a MySQL database or an Oracle database, but it's going to do the basics. It's going to let me make tables, and it's going to let me put stuff in those tables, and it's going to let me get stuff out of those tables. And for, you know, a large portion of the apps that we create, that's what we need. That's enough. That's enough to get the job done. Yeah.
Do you post the code for these?
I do. Yeah, I posted the code for everything, I believe. Yeah, it's up on Canvas. On the calendar page. Yep. I don't post them till I'm done though, so this one's not been posted yet. I'll post it after class once we code it up. So today we're gonna see how we access a database, and we're gonna use a library, just like we used a library last week to access API calls. This week we're gonna use a library to access a database. Do you have to use a library to do that? Not necessarily. There are more manual ways of doing it, but the library makes things a lot easier and you know, really simplifies how quick you can get something up and running. The main process is going to be the same though. We have to identify what our model is going to be. We have to make a Kotlin object to represent our model, and then hook that up to the library, just like we did for the API last week. We made a little Kotlin class that you know, mirrored the API calls that we were making. This week we have a little bit more control. We get to define the structure of that. So it's not like we're trying to copy the structure of the API calls. We're actually responsible now for determining the structure of our model in a lot of cases. So that gives us a little bit more flexibility. We'll hook it up to a database. We'll set up a repository, which is responsible for actually accessing data from the database. And then we'll have the Viewmodel, which sits in between the repository and the view to pass data back and forth, just like we did last week. So it'll be a good review of the model view Viewmodel architecture that we have been using and are going to continue to use in this class, while using a slightly different form of model than what we used last week. So the app that I'm going to make today is kind of a trivial app. I wanted to make an app that let you keep a list of jokes. So you tell me what the setup is and the punchline of the joke, and then it stores it in a database. And then if I want to see a list of all the jokes that I've stored, I can see a list of all the setups and punchlines. It doesn't really do much more than that. In fact, you could use it for anything, right? It doesn't necessarily have to be jokes. It's just storing data in a database and pulling the data back out. So the first thing we're going to do is we're going to set up a model. We're going to set up a model. So in this project that I've already got set up, there's a folder here that I've made for the database related stuff. I'm gonna put a Kotlin class in there for my model, and it's gonna be a very simple class. Recall from the API stuff that we did last week that, you know, these model classes are typically very straightforward. There's not a whole lot of code required. They're not terribly complicated. A lot of times I can just use a simple data class. So I'm gonna make a data class for a joke. And I need to decide what values this data class is going to contain, and I'm just going to keep it very simple. There's a setup and there's a punchline, right? The setup would be, why did the chicken cross the road? Punchline would be to get to the other side, as one very bad example of a joke. So I'll make a setup, which is a string, and I'll make a punchline, which is also a string. And I need a comma in between those two. Something else that we might want to do is have some kind of a unique identifier, right? Because it's possible that, so if I asked you, you know, what makes a joke unique, right? The punchline's not always going to be unique. Some jokes have the same punchline. And the setup's also not unique, right? How many chicken cross the road jokes are there? Like millions. Too many, right? So in order to help us uniquely identify a joke, it may be worth our while to include a third value here, which is just going to be an ID. It's just going to be a number, right? I'm just going to number every single joke so that I have a unique value assigned to each one. Is this strictly necessary? Actually, it's not, but it's a pretty common thing to do. It's something that I would expect you to see relatively common when setting up, especially when working with a database. And so here's our data class, right? This is our data class. Now, to understand how this library works, we're using a library called Room to manage the database stuff for us. To understand how this library works, we need to point it at a model. We need to tell Room, hey, this is the object that I want you to store in the database. And here are the different pieces. And then once we give it that information, it will make a table for us automatically. We don't have to make the table. It will also give us some very basic functionality as to how to put new things into that table and get things out of that table as well. If I want to do more complicated things, I can, and we'll talk about how to do that a little bit later on. But perhaps the most important part of setting up something to work with a database is annotating your model. We have to annotate the model. The first thing that we're going to do to annotate this model is slap an entity annotation up here. This is telling Room, quite literally, that this is the class that I want to use as the basis of a table in my database. If I want to, I can specify some additional information, such as what do I want this table to be called? If you don't include this, I'm pretty sure it will just default to the same as the name of the class. So I'm telling Room with this annotation that I want a table to be made to hold jokes. And I want that table to be called jokes, right? That's what that annotation is telling the Room library to do. The next thing that we need to do is specify some properties about each of these fields of the class. So how many of you have done database work before, SQL stuff before? I see it's about 50-50, it looks like, actually. So it's a good portion. So those of you who've done database stuff before, you might, or you probably will already know a lot of the stuff that I'm about to talk about, but I'm going to try and be very thorough here for the people who haven't done a lot of database work before. We're going to set up some properties that relate to how these values are going to get stored in the database. So for example, there's a way to specify what I want the names of each of the columns to be in this table. So if we're envisioning what this database looks like, I have a table called jokes. Right now it's going to have 3 columns: ID, name, and ID, setup, and punchline. ID, setup, and punchline are the columns that I'm expecting to see. And so for every joke, I'll just see the values, right, in those columns. It's a very simple table. But I need to tell the library that I want these things to become columns by attacking a column info annotation above them. And if I want to, I can go a step farther and say, call this column setup, right? It's a little bit redundant. It's a little bit redundant to have to say this. In fact, I think if you don't say this, it will probably default to calling it setup anyway, right? But I did want to show you that you do have control over what the actual columns in the database end up being called. So we can do something similar for this one, right? Now for this int column up top, the ID column, remember that the whole reason that that exists is to have a way of uniquely identifying each joke that exists. And in the database world, we have a name for that. It's called a primary key. This is going to be our primary key column. So a primary key in a table is a column that uniquely identifies each row. And the most common way you're going to see that is with a number that just counts up. 1, 2, 3, 4, right? Every column's just going to be numbered. And so instead of using column info here, we'll mark it as a primary key. And not only that, we can take this a step farther and say that I don't need to tell you what this number is. You can just go ahead and make this number up yourself. We can let the database specify what this number is. I know how to count, right? I don't need to write code that's going to count this up. The database can generate this for us if we use this auto-generate equals true property of the primary key. And what that means is that we no longer really need to worry about setting that value. We just need to come up with objects that set the setup and the punchline values, and the database will take care of creating a unique number for every single joke. Are there any questions so far? Any questions so far? So we've annotated our model. We're telling the library, here are the different pieces, and here's where I want them to go. Yes?
So the auto-generated just would be the equivalent to like auto-increment in SQL. So
Yes, auto-increment, exactly. I suppose technically it wouldn't have to be auto-increment. It could just pick numbers at random, but I'm pretty sure it just counts up. Yes. Any other questions? All right, so now that we've annotated our model, we've told Room that this is where we want this is what we want the database to be modeled after. And by the way, I'm not limited to just one of these, right? If I want to have multiple tables, I can make multiple data classes and annotate them all, and it will happily accept as many of these as I want. I can have as many entities as I want to. So that's all within the realm of possibility. So now that we've got that taken care of, we're going to set up a couple of other pieces that are going to help us access these jokes when we need to access them. So the next thing that I'm going to make is a very special kind of Kotlin. A very special kind of object called or actually it's technically an interface called a DAO, a data access object. It works very similarly to the interfaces that we saw when working with the API. The syntax is a little bit different, as I'm about to show you. But the data access object basically defines the methods that I'm going to use to access the database. So let's go ahead and start piecing this together. I'm going to make an interface called joke DAO. And then inside of here, I can make methods that are going to, or functions that are going to get jokes, right? I expect this to just get all of the jokes. All of them. Just give me all the jokes that are currently in the database. And what's the return value that I expect to get here? Well, here's our good friend live data. We saw live data last week. We're going to use live data again this week for the same reasons that we used it last week. What are those reasons? Anybody remember why we used live data? What the advantages were? Yeah.
If the data is changed while you're using it, then your application will be updated.
Yeah, that's probably the top of the list, right? We can put an observer on that will fire off anytime that the data changes, and then it will automatically update based on that data change. Yeah.
Is live data thread safe?
Is live data thread safe? I honestly don't know the answer to that question. I do not know. We are going to do a little bit of thread stuff today. Not a lot. Not as much as last week, honestly. But for the purposes of this app, I don't think it matters. But I could see how it could matter in other contexts, perhaps. And so a live data of what? What do I expect to get back? I expect to get a list of jokes. A list of jokes. And now, here's where a little bit of SQL comes in. This is not a database class, right? But we are going to need to know at least a little bit of SQL in order to use this library properly. And again, the people who told me they've already done SQL before, you're probably already familiar with the basics. So what I'm about to say is probably going to be a little bit of review for you, but I'm going to tie a query to this function, and this is the SQL query that will get executed on the database when this function is run. So I'm tying a SQL query to this database, a query that will be sent off to the database and executed whenever this function is called. And the query is just going to be extremely simple. It's just going to be select star from jokes. This is kind of the hello world of SQL queries, right? But just a quick breakdown, if you're not familiar with SQL queries, the select and from are keywords, or in SQL we call them clauses, where the select clause specifies what columns I wish to retrieve. So of the columns that are available to me, which columns do I want to get back? By putting a star here, I'm saying I want them all. Give me all of the columns, right? Give me every single one. The from clause specifies what table I want to pull the data from. So if I interpret this query in English, I'm saying, give me all of the columns from the jokes table, where the jokes table is exactly what I specified as the name of the table when I define my entity in the model. So this very basic query will just give me all of the jokes that are in the database. Now, if you are more familiar with SQL syntax and you want to write some more advanced queries here, you can. You have to be a little bit careful. It doesn't know every single piece of SQL, or it won't be able to execute every single SQL command that you can think of. It's a limited set of SQL commands, but you know, it knows most of the basics. And in this class, we're not going to do anything that is terribly complicated SQL-wise, unless you choose to do so as part of your creative portion or on your project, of course. And so this gets us data out, but we still have a couple of other things that would be useful to us, such as how to put data in. How do I add more stuff to the database? So I'm going to make another function. This one's going to be even more simple than the last. I'm going to make a function for inserting. And I'm just going to go ahead and annotate this with an insertion annotation. Oh, I'm sorry, it's just insert. My fault. This tells Room, the database library, that if this function is called, I want to take whatever this joke value is and put it in the table. It takes care of the rest. And then last, we'll write one more that is just going to be used to delete. And I'll write a very simple deletion query here. Delete from jokes will delete everything that's in the jokes table. Another very, very simple SQL command. And so I can continue doing this, right? However I need to access the data, however I want to use this database, I can keep adding functions here and tying SQL queries to those functions that I can then use in my view model, or to access the data and pass it to the view later on. Or actually the repository as well, which is something we're going to be getting to very shortly. Are there any questions about this data access object? It's a pretty critical piece of the whole operation. Pretty critical part. Cool. So then our next stop is going to be setting up the database itself. So the next little chunk of code that I'm typing in is kind of boilerplatey, which means that if I ask you to use a database, you are more than welcome to just use this next chunk of code verbatim or close to verbatim. But I do think it's important to understand what it's doing. I'm not opposed to using boilerplate code in my apps, but I don't like to just slap it in there without understanding what it's for, what it's doing. So we're gonna type this out, and we're gonna take a peek and try and figure out exactly what's going on in this as well as we go through. So I'm gonna make a class. In fact, I'm gonna make an abstract class. This is something that I imagine is probably a little bit new to some of you. Is anybody familiar with what an abstract class is? Some of you might have gotten 332. Somebody want to explain it? Yeah.
I didn't want to explain.
Oh, okay. Somebody else want to explain it?
Well, I can't explain.
You don't have to.
Well, it's basically just a class that defines some structure but has at least one method unimplemented,
Mhm.
like a pure virtual.
Yeah. So, yeah, exactly right. So an abstract class is going to have some methods that don't have implementations associated with them. Why that's important here is the room library is going to take care of that implementation for us. Again, very similar to how the Web API library that we used last week, Retrofit, handled things. We provided it with the specification via an interface, and it took care of actually doing the implementation. It's the same kind of concept here. And so the abstract function that we're going to implement is actually one that lets us access the data access object that we were just looking at in the previous file. So this is an abstract function. I'm not going to specify how this function works. I'm going to let the room library take care of that. I'm basically just putting in a placeholder, and then I'm saying, all right, the room library is going to take it from there. It's not something that I need to worry about anymore. And then there's one more thing that we're going to do here. When you're accessing a database, it's actually somewhat resource intensive, right? In this case, the database is really just a file or maybe even a series of files. And so accessing those files is not cheap. It's rather expensive. And we want to be careful. I don't want to have multiple copies of this database at the same time trying to access those files, because that could really start to bog things down. It could really start tanking my performance. And so the common practice that's expected here is to use what's called the Singleton Pattern. I'm going to write some code that ensures that I will only ever have one reference to the database in this program. Again, the reason being that if I allow multiple references to the database, I could have lots of data access happening at the same time, which could slow my app down or even crash it if I have too many resources being used. So all of the code that I'm about to type next, and it's a non-trivial amount of code, is all serving the purpose of trying to enforce this Singleton pattern. In fact, I'm even going to put a little comment up here. Singleton pattern. What's a companion object in Kotlin? We've seen that before briefly. It's like a static variable, yeah. It's like a static variable. And so the static variable in this case is actually going to be an instance of the database. We'll start it out as null. We'll take care of that a little bit later on. Okay? The next thing that we're going to, the next thing we're going to do is make a little function called getDatabase. And again, this function is trying to provide access in a way such that we know that there will only ever be one copy of the database in this app. So the first thing we're going to do is check to see if this instance is null. If this instance is not null, then we know that the copy's already been made. I'm not going to make a new copy. I'm just going to give you back the copy that already exists. So first thing we're going to do is check instance. If it's not null, then just return it. Oh, I forgot to set the return type. Sorry. Let me scooch this over so we can actually see. Why are you still unhappy? Okay. Oh, I see. I see why I might be mad. I'm gonna pause. I'm gonna let that be angry for a second. We'll come back to it later. And now, actually, I'm gonna address something that was asked before about thread safety. If I have multiple threads trying to access the database at once, that could be a problem because then they could both get a reference back. So I'm going to use a keyword here called synchronized that is basically saying only one thread can enter this block at a time. Only one thing can execute this next chunk of code at a time. That will ensure that I'm not going to mistakenly give back multiple instances. And then here I'm just going to create an instance of the database. And again, I'm going to use a pretty standard format here. We have to pass in the context, which the context you can think of, actually somebody was asking about this on Piazza, I believe. A context is something that's provided by an activity. So when you think context, the activity is probably what is the right thing to put there if something asks for a context. We're going to specify the database class that it should implement, joke room database class.java. We're going to give it a name. So this we can call whatever we want. I'm just going to call it joke database. And then we're going to call .build. Why are you mad at me now? Did I skip something? No, I didn't skip anything. Oh, I skipped a comma is what I skipped. There we go. I got a comma. I'm going to stash this instance in my variable and then return it. I'm sorry? This one?
Yeah.
So it's still mad at me, and I have a couple ideas as to why that is the case. If I look at the error message here, it says SmartCast is impossible because instance is a mutable property that could have been changed by this time. So it's saying that because this is marked as var, something could have come along and modified this before I return it. That's my interpretation of that error message. I could be a little off, but that's my personal interpretation of this. And so it wants something that is, a val perhaps. So you could, this feels a little hacky if I'm being honest with you. Make a temp. No, it still didn't like that. Type mismatch. One is the nullable type, the other one is not. But I've checked, and then I should check temp to see that it's not null. Yeah, there we go. Yeah. It's a little hacky, yeah.
How expensive is that copy?
How expensive is the copy?
Yeah.
It's just copying a reference. References aren't very big. It's not making a copy of the entire instance. In fact, we never want to make a copy of the entire instance, right? That's the whole.
Is that guaranteed? That it's not doing any kind of copy assignment?
Well, Kotlin is based on top of Java, and Java's passing references around everywhere. So, yeah. So yeah, it's making a copy of the reference. It's a shallow copy for sure. Of that, I am positive. Again, if a lot of what I said is sounding like gibberish to you, and you haven't had a lot of parallel programming experience, that's okay. I'm never gonna grill you on this stuff, and you're welcome to use this boilerplate and just kind of treat it a little bit as the magic words that make your program go if you want to. I don't have a problem with that, but I am a big proponent of understanding what you're putting in your app, even if it is boilerplate code. So I thought it was worthwhile to at least take a little bit of time and explain what this code is doing, even though I doubt that you're ever going to have a need to change this code very significantly in your own apps. Are there any questions about it before we move on to the next thing? Okay. The important thing to understand about this, if you take one thing away from this file and what it's doing, it's that there is one instance of the database that exists at a given point in time. I'm not going to allow multiple instances of my database to exist. Yes?
So just a question on this function in general and getting the call for the abstract class. So what's going to call the abstract class, and isn't that going to set the instance to null every time it gets called?
So get database is a function that we're actually going to call in the where are we going to call that? In the repository or in the no, I think we'll call it in the repository. Actually, might call it in the view model. I'm trying to remember where that call comes from. But regardless, this class, again, remember, is abstract, which means that the implementation of this class is actually going to be done by the room library. And so it's connecting a lot of these wires up behind the scenes. And I kind of have a similar rant that I had last week about the room library. It does a lot of work for you, but you don't get to see a lot of that work, right? And that kind of bothers me a little bit. You just sort of have to cross your fingers and trust that it knows what it's doing. And if things go wrong, since you are seeing only like the top layer and not the layers that are going down underneath, it's a lot harder sometimes for you to figure out what's causing these kinds of problems. There is one final thing actually that I forgot to include on this class. We have to annotate this as well. And I want to double check and make sure that I remember to annotate my DAO as well, DAO. I have to annotate this with the database to indicate that it's the database class, and then pass some information to this. I'm telling it what my entities are. My entities are going to be an array of jokes. This is a very important part. It would not have worked if I didn't include it. And then I also need to include a version number, I think. Version equals 2, which I believe is the most up-to-date version of room. So these annotations, right, are very important. One of the more common mistakes that I personally make, and that I see other people make as well, is they forget to tack those annotations. We've used a lot of them. I've got annotations in this class. I've got annotations in the DAO, in which I forgot one, right? I need an annotation here to tell room that, hey, this is my data access object interface, right? That would have caused a problem if I forgot that and didn't go back and pick it up. And we also had annotations on the entity. And if you forget any of those annotations along the way, it's going to say, I don't have a proper implementation. That's a very common error message. Yeah.
If I try to access the database and pass some context into it, and then let's say I keep that object around in some sort of global cache, and then I try to access it from a different context, is that an issue?
So you said the word cache. I mean, there's one other thing that I sometimes see people do that may answer your question. I'm not entirely sure, but Kotlin has a keyword called volatile, which is very similar to the keyword you might have seen in other languages. It basically says, always fetch this from memory, never use a cached version of this instance, right? And that way it's even stronger enforcement of the idea that I just want this one, right?
I was asking, like if I have two different activities,
yeah,
right, and then I get the database from like my first main activity,
okay,
and then I transfer over to some other activity, right, and then I'm calling it with the context of.
So here, right, you're calling this one?
Right, I'm calling get database with the context
Mhm.
of the second activity.
Mhm.
So I built the database using the context from the first activity.
Okay.
Is that an issue?
I don't think so. Again, having multiple references to the database isn't a problem. So having the reference to the database in multiple contexts isn't necessarily a problem. It's having multiple instances of the database that is a problem.
Right. It just seems as though like we're taking the application context of the context that you pass in.
This one, right? Is that what you're referring to?
Yeah. So why would we even do that if it doesn't even matter what context we get it from?
Well, actually, back to your original question, I mean, wouldn't the application context be the same for both contexts that you pass in? Like, wouldn't this be equivalent, or am I misunderstanding?
I actually don't know.
Yeah. I think it would be equivalent. I think the application context would be the same for both, which again kind of answers the question that it wouldn't matter in that case. But yeah, it would be worth digging a little bit more into it to verify that that is in fact the case. Any more questions about this piece? The piece that again, I'm saying this mostly in case anybody's sitting out there right now very, very terrified about all of this discussion about threads and things like that. I want to make it clear, right? The piece that I'm more concerned about in terms of this class is that you can set up your entities, you can set up your data access object. To me, in terms of creating a mobile application, those are the critical pieces, especially when you're just starting out with this stuff. The threading is not something that needs to be a huge concern when, you know, this boilerplate code handles 99% of the problems that you're going to run into in most cases. And so then with that in mind, we're going to move on to the repository, which we had a repository last week when we were working with retrofit. We also had a repository, and the same thing's true this week. In fact, I want to make it clear that under the model view model architecture, there will always be one repository. And so if I ever have an app that uses both retrofit and room, for example, right? If I ever have an app that needs both, I would still just put them all under one roof, under one repository. All data access is going to go through that repository. So the stuff that we've done so far is very specific to the database, whereas the repository is going to handle any data access outside of the app that needs to occur. So we're going to set this up next. We're going to call it joke repository. And this is a pretty straightforward class, just like it was last week. Actually, last week it wasn't. It's even more simple than last week, actually. We're going to continue to use coroutines just like we did last week, but in an even simpler way than we did before. I'm going to start by making a variable to keep all of the jokes, and it's going to be a live data again. And I'm going to I forgot to add the parameter up here. I'm going to pass in a reference to the DAO. I'm going to pass in a reference to the DAO because, again, that's how I access the database. That's the object that I'm using to access the database. So in this case, I'm going to use the DAO and call the getJokes function on it because that's what's going to go to the database, retrieve all the jokes from the database, and store them in the live data object. So now I already have a live data object set up that has all of the jokes in my database. And again, just like last week, Room is taking care of all of the mapping. It's going to take the values from this column and map it to the appropriate instance variable in my joke object. It does all of that, and the annotations are what makes all of that work. And now I'm just going to make a couple of functions, one for insertion, which is going to insert a joke, and it's just going to call the insert on the DAO, and I'm going to call another one for clear, which will delete all the jokes. And it's just going to call the delete function on the DAO, and they're both going to look very, very similar. They're going to use coroutines just like we did last week. Similar, but not exactly the same way. Dispatcher.io. That's the same dispatcher we used last time. Launch, and it's very simple. Joke DAO dot insert joke. Don't need a semicolon. Import some stuff. That's plural. It's supposed to be. Import some stuff. All right. So I'm launching a thread that's going to access the database and insert this joke. I'm actually going to copy this and move it down here and do a similar one for deleting. And our repository for this app is actually finished. So think about, I didn't mean to do that, sorry. Think about what we've done here. I've made my repository access the database functions through the DAO object. The view model then is going to be the middleman that stands in between the view and the repository. We're almost up to the view piece of our app again. Question, yeah, go ahead, sorry.
Sorry, I'm kind of not really understanding what the difference is between a joke repository and and the joke database.
And the joke database. All right, so the joke room database, the one that we were just doing here.
Yes.
So the joke room database is really, you can think of it as like a placeholder it's basically a placeholder class that the room library is going to come through and set up all of the implementation that it needs to make things work. And we don't actually get to see all of that happen. That happens under the hood, behind the scenes. But it's going to set up stuff like, how do I map stuff from the table to a Kotlin object, right? How do I take a row out of a table and turn that into a Kotlin object? That's the kind of stuff that this joke database is going to do. It's going to set up stuff like, where is this file actually stored that contains the data? You know, that file's got to go somewhere. Do we as developers care where it goes? Not necessarily. I'm going to let the library handle, you know, here's the file that I'm going to use, here's where it goes, and I'm going to put all the data in that file. And all that stuff's going to be fleshed out, again, by the library for us using this class, whereas the repository is sort of the app-facing side. If I need to access the database, the view model is going to call these functions, which will then actually enact the database calls that need to happen.
So
Or, yeah, go ahead, sorry.
Our database object is the view model object.
Not quite, no, not quite. There's a hierarchy going on here.
Okay.
And every time we take a step up the hierarchy, we're just making another layer of abstraction, basically, right? So the database is probably pretty low on the hierarchy. The repository is another level up. So it's saying, when I call a function on the DAO object like this, it's saying, go make this database call. I have no idea how you're actually going to do that, right? Like, I don't know what the file is. I don't care where the data is. I just want you to do it, right? And then the joke database object will take care of all of those details for us, right? It's abstracted out. So the repository is just a very high level way of accessing the database. And the view model is even higher up than that, right? The view model says, I don't even care if it's a database or not. Like, I don't know where this data came from, right? Just give me this data. I don't know where the jokes are. It could be in a database, it could be an API, it could be, like, I don't know where it is. Just give me some jokes so that I can put them on the screen. That's kind of how the view model sees the world. So each layer of abstraction that I go up can't really see anything other than the layers that are right next to it. Does that make sense? The repository is talking to the view model and it's talking down to the database, but it doesn't really know what the database is doing. That's not its role. It just knows how to contact the database. The view model knows that the repository exists and has ways of accessing data, but it doesn't know that the repository is talking to the database object to get that data, right? And it doesn't need to. It just wants to get the data. Does that help? Yeah. I hope. And then when we get up to the highest level of abstraction, right, the view, if I'm using the app, right, I'm a user on the app, I don't care where that information comes from, right? It's not, I mean, as developers, we kind of care because we're interested in that sort of thing, but you always think of your generic user. I always think of my mom, right? My mom doesn't care that data is in a database. She has no idea. She doesn't want to know. She doesn't have to know. She just wants the thing to work when she pushes the button. That's all she wants. So that's kind of the highest level of abstraction that we've got. I hope that helps clear up the structure. It will get better with practice. We're going to keep using this structure over and over and over and over again throughout the class. So our repository is done. I think our next stop is, in fact, the view model, which, where is my view model? Here it is. The view model is going to be set up in a very similar way to our prior view model. It's just going to have a few calls down to the repository, right? Again, it knows that if it wants data, it can go to the repository. It doesn't know whether it's a part of a database or an API or some other kind of thing. So we're just gonna write a little constructor here for this that's going to that's going to initialize the repository. And in order to do that, we actually need access to the data access object. So that we can pass it in. And here's actually a call to get database. Here's a call to get database, which is that Singleton pattern that we've spent a lot of time today talking about. And we're going to pass in the application context. So this is kind of a long line of code. I can't even fit it all on the screen. But basically, we're creating an instance of the joke repository, which needs the data access object to function. So we're grabbing the data access object from the database to pass to the repository. How am I doing for time? Well, I'm doing pretty good. Okay. And then we're going to set up our joke list to track with the live data object from the repository. So now any modifications that happen to the list in the repository will also be reflected in the joke list itself. And from there, we just have a couple of data access functions for the view model, one for getting all of the jokes, one for inserting jokes, and one for deleting jokes. I forgot a return type here. Not a list, a live data list joke. These are very simple. Joke, and then okay. So these are the functions that we are including in the view model, so that when the view needs a new copy of the data, or needs a refreshed copy of the data, or needs to perform some action, right, based on user input or some event that takes place, we can use these functions in the view model, which then take care of passing that data along to the repository, which then decides where that data should go and passes the data then to the database, which takes care of the actual storage of the data. I know it seems like a lot of channels to get from the top back down to the bottom, but again, remember, it's all about what level of abstraction we're currently dealing with. The view model doesn't care where the data comes from. It just lets the repository deal with that. The repository doesn't care about the actual details of storing or retrieving data. It's just going to pass those clues on to the database or the API and let it handle that from there. And we're actually almost done to start seeing some stuff hooked up. There's actually only one more file, I think, that I have to write code in before we can actually test this out. And it has to do with the view. I wanted to introduce a different way of working with views today that you probably haven't seen before, or you've probably seen it in an apps before, but you probably haven't seen it in code before. I wanted to introduce a way to do like a tabbed view, right? Where I have a series of tabs at the top and I can select which ones I want to navigate to. In Android, that's going to be called a pager, which makes it sound like those things that people used to wear that beeped and had phone numbers. I don't know, that probably way before you guys' time. Yeah, but that's not what it is. It's tabs. It's for tabs. And so in the main activity, if we take a look at the layout for this real quick, for the main activity, I've included in the main activity, right here, we can see I've included a tab layout and a view pager. So a tab layout is what displays a single tab's worth of information, The view pager is what displays that little thing at the top that lets me select which tab I currently want to have displayed on the screen. That's the role of those two things. There is a little bit of coding work that needs to be done to hook this up, though. We need to specify how many tabs we want, right? And we need to specify which fragments are associated with which tabs. That's the work that we have left to do to set all of this up. And so we're going to do that in the main activity. We're going to create a little class here called a pager adapter. And we've heard that term adapter before, right? An adapter is just used, we've been using it for primarily lists. It doesn't have to be lists. When you hear the word adapter, your brain should just think, oh, I'm taking data of one form and converting it into a different form, right? A form that can be more easily displayed. And that's what's happening here as well. We're making an adapter to show how tabs should be properly displayed. So I'm going to make a pager adapter class. It's going to accept the fragment manager because as part of the pager adapter's job, it's going to swap fragments in and out as I select different tabs. So it needs the fragment manager to do that, much like we've seen the fragment manager used to swap out fragments in other apps. Okay, and then we are now obligated to implement 3 functions. We need to implement a function that specifies which fragment is tied to which tab. We need to implement a function that specifies how many tabs there are, and we need to implement a function that assigns titles to the tabs as well. So they're all pretty straightforward. We'll start with perhaps the simplest one, get count, which is how many tabs are there. In this case, I'm very simply just going to return 2. I've been forgetting my return type on like every single function today. My brain is just not working that out for whatever reason. So I'm going to have 2 tabs. I'm going to have a tab that lets me put a joke into the database and another tab that lets me see all of the jokes in the database. Those are my 2 tabs. In fact, the fragment code for that is already hooked up. We'll take a peek at it in just a second. But I already have those fragments coded up. The joke list and the add joke fragments already exist. The next function will be the one that ties fragments to a specific tab. That's called get item. And it takes a position as an argument. And then we usually just do a little switch statement, although it's a Kotlin style switch statement. Return when position 0, add joke, else joke list. What are you angry about? Oh, return type is fragment. Again, with the return types, I don't know what my deal is today. So this is a little Kotlin style switch statement, switch case statement. I'm saying that the add joke form is tab number 0, and the joke list is tab number 1. It's the only other tab that there is. And then last, we're going to write a very similar function to this one that just assigns a title to the tabs. Get page title. Again, it's going to accept the position as an int. It's going to return a char sequence, which is like a very fancy name for a string. I wonder if you could even use string there. Probably doesn't matter that much. And we'll just do a similar thing. Return when, another little simple switch statement. 0 will be add joke, else joke list. Just applying titles to the tabs. And at this point, unless I screwed anything up, I'm fairly certain that the app is done. Before we actually test it out and run it, though, I think it is probably a good idea to take a quick peek at the fragments, because they are the ones that are going to be interacting directly with the view model. I talked about that a little bit in Tuesday's class last week, but I kind of ran out of time. So since we do have a good 15 minutes left, I would like to make sure that we take a peek at how these are working and what they're actually doing. So the onCreate and onCreate view is all pretty standard. The stuff that's different is in this onViewCreated lifecycle event function, where you can see I'm accessing the view model, and then I've got a button for submitting new jokes. It's going to create a new joke object based on whatever text is typed into the boxes. I've got one for the setup, one for the punchline. Notice that for ID, I've just hard-coded in a 0. But wait a second, right? Hold on, does that raise any alarm bells for anybody? Think about what that means.
The primary key in your.
It's the primary key in the database. So why am I setting a value here? I mean, there's a good reason for that. One is that if I take it off, it gets mad at me because the constructor of my data class requires an ID value, right? Think about what this means. Think about what we're actually saying here. I could just leave the 0. Think about what we're actually saying in the code here. Kotlin requires that I provide some value for that. I don't know what the database is going to use for that value. That's going to be auto-incremented. Whenever this gets inserted into the database, it's going to take that ID, throw it out the window, and reassign whatever ID it wants on there. So it doesn't matter, right? I've marked it as auto-increment in my model. It does not matter what I put in there.
Could you send in null?
Could I set it to null? I don't think ints can be null. It does not like that. Oh wait, maybe if I put the comma? Yeah, it still does not like that. I think it has to be an int, right? I don't think ints are allowed to be null. Yeah.
Could you not have it in the constructor, but then just have it as like a something in the body? So you don't.
Yeah, so I could write code to make that work, but then I wouldn't be able to use this convenient data class, and it would actually end up being more code, I think, for me to take it out of the list.
Don't they auto-generate getters and setters?
I'm sorry?
Don't they auto-generate getters and setters? So if Broom uses the getters and setters to change ID, can you just have like a public field in the data class?
Yes, you're correct. Actually, I probably could just change this to a public field. What would that look like? I would probably just put it down here as
Throw some braces on it.
pop it in like that. Maybe this is a better way.
If you need like an equal 0 or something, it's not visualized.
It's not mad at me. There we go. Yeah. I see what you're getting at. Perhaps a little cleaner way to make it work. And then I can take the... Whoops, I was in the add joke. And I can take this out. All right. I mean, I can tell you from experience, I've tested this app, and having the 0 there does absolutely no harm, no damage. And actually, it requires extra curly braces that I wouldn't have otherwise needed, but I don't even know that it has to be public, does it? Could just be public by default. It does need to be able to be accessed, though. Yeah.
I think it has to be a var.
You think so? Yeah, because it'll have to be changed later on, right? I don't know. I'm interested to see. Yeah, we'll see. We'll run this in just a second and see what happens. But anyway, going back to this, right? It makes the joke object, however that object gets created, and then calls the insert to. So this is where that chain reaction happens, right? I tell the view model to insert this joke. The view model says, all right, I'm going to pass this along to the repository. The repository says, oh, you're inserting this, then I need to pass this to the database. The database pulls the values out of that object, creates a SQL statement, actually, to insert that into the database. We don't get to see what that SQL statement is, although it's not complicated. It's very simple. And then actually sticks it inside the database. And then we just put a little message saying that the joke was added. And then on the list side, it's kind of the same idea. I've got a recycler view for my list of jokes. I have a list adapter that I'm not even going to show you because it's like the 5th time that we've seen a list adapter in this class. And then I set up an observer on the joke list, and if I see any more jokes get added or deleted, I'm just going to clear my list and add all the, that should be jokes, whatever. Add all the new ones, jokes, and update the UI. And then I've got a clear button that will delete all the jokes in the database, which is just tied directly to the clear function from the Viewmodel. Let's try it out. It's possible that I made a mistake somewhere. You might even say it's likely I made a mistake somewhere, and I wouldn't necessarily disagree with you, but let's try it out. The nice thing is that I do have a little bit of time to fix problems if they do in fact exist. While this is setting up, we can kind of recap what we've talked about today. Oh, and one final thing actually that I should have mentioned, that I forgot to mention. This is important because you're going to do this in a project someday, and you're going to do what I've done and every other person who's tried to use Room with the Kotlin project has done. This is a very common mistake that happens when using Room with Kotlin. In the Gradle file, there are some things that we need to include. Whoops. Yeah. All right. Let me start that up again real quick. There are some things that you need to include in the Gradle file for Room. I don't think that should be surprising at this point, right? It's a library. We need to include stuff in Gradle so that it can access the libraries and do what it needs to with the libraries. The one thing that I think is worth pointing out is that if you put the Room stuff in here, it starts with a different word called capt, K-A-P-T, which is a Gradle command. It's a special Gradle command specifically for Kotlin-based libraries. And I have to fully admit that the details about this particular command are a little bit lost on me. But I do know from a functional perspective that if you don't do this, if you don't use the capt keyword here and you use implementation instead, that it will not work. Your room implementation will not work. And furthermore, since capt is a specialized command for Kotlin, in order to even use it in your Gradle file, you have to include this line up at the top to apply the capt plugin to even be able to use it in the first place. I ran into this the first time I used Room. There's like 1 million posts on Stack Overflow of people who've tried to use Room in Kotlin who've ran into this problem when they first set it up. I imagine somebody in this class is probably also going to run into that situation. So I just wanted to point it to your attention now. In case you do see some problems, one of the first things that I'm going to ask you to check is, in your Gradle file, do you have this plugin enabled, and do you have the Room dependencies set up to use capt as the command here? Because that's a very common thing that I see. The next question, if you're having Room problems specifically, the next question I'm going to ask you is, do you have all the annotations? Because that's probably the second most common thing that I see. Forgot to put the DAO annotation. Forgot to put the database annotation. I've done that before too. I'm going to do it again sometime. I almost did it today. It's going to happen. Very common kinds of things that you might run into. So one of the problems, again, with using Room is that if things go wrong, that I already know the error message you're going to get. It's going to say something like, could not find database implementation for such and such. But it very rarely tells you why there isn't a database implementation for such and such. And then you're on the hook to try and figure out what it is that you forgot. So those things in particular, the Gradle file stuff and the annotations, are two of the most common reasons why that error occurs if you run into that error. So those are going to be the first things that I'm going to ask you about if you're having Room errors when you're coding up these apps. And I've got a blank screen. That's not a good sign. So I screwed something up. I'm not surprised. But what did I screw up? I know what I screwed up. I see it, actually. I accidentally a thing. There's one final thing that I needed to do to set up my my tabs, and I forgot to put it in my activity. I needed to actually create an instance of this class. I made this class and then I never made an instance of it. So, whoops, my bad. At least I figured it out pretty quickly. Fragment, adapter, doesn't matter. My pager adapter. So we're setting stuff up with the app to use this new adapter. And then there's one more line of code. I'm accessing the tabs view and saying use this view pager. Oops. Yeah, that's why I was staring at a blank screen. I didn't type in these last few lines to properly set up the tabs. I need to make an instance of my adapter, pass that to the view pager, and then pass the view pager to the tabs view. And now if we rerun this, I'm a little more optimistic that it might actually do what I intended for it to do. Are there any questions while this is recompiling? Yeah, what's up?
So like, if I want a package from like Node, I will go to like npm and find the package and then put in my package.json and it knows what to do. Right?
Yeah.
So where are all these Android packages coming from?
Google. It's actually one of the most frustrating parts about Gradle. There's not an easy way to find them. A lot of them are just found online by looking them up. And the reason why that's problematic is because if you are looking at a Stack Overflow post from 2 years ago, you're going to be pulling in the wrong version, right? Sometimes, I actually ran into this last semester. We were using a library called Firebase. Actually, we're going to be using Firebase here in a couple of weeks. And there was a version of Firebase that came out that was known to have very serious issues that just happened to be released, right around the same time we were using Firebase in the class. And so, how do you get that information? You start Googling Firebase errors, and eventually you come across a post that says, warning, this version of Firebase is a big old piece of crap. Don't use it, right? How am I supposed to know that? You just kind of have to, as of right now, the answer is you got to stay on top of it. You got to read the blogs. You got to do some furious Googling. It's not a great answer. Now, that being said, Gradle does, I think I have an example of this in my Gradle file, do a pretty decent job. If I hover over one of these, it says a newer version, right? So if I want to, it'll tell me that a newer version of this library exists, and I can update the Gradle file to use that newer version if I want to, or not. It's up to me. But how do I get this in the first place? It's in the documentation for the library. Just got to go look it up. Yep. Not a satisfying answer, but so here's the app, and it's very simple. Let me show off the tabs first, right? You can use swipe motions to go back and forth, or you can click on the tabs at the top. Either way, and it'll switch back and forth between the tabs. And remember that when I do so, I'm actually looking at two different fragments, right? So here's the very simple form to enter jokes. Whoops, hello. Hey, don't do that. All right. What is brown and sticky? A stick. Oh, yeah, that's right. Joke was added, and then if I go back over here to my joke list, I now see there's a new entry, right? And I can go back and add another one. I don't have any more dumb jokes. Actually, I probably do. I think probably all of my jokes are dumb, but I don't know. Here's a joke. I don't have any jokes. I don't know. What's a joke? Gibberish. Doesn't matter. Not a very funny joke. And then you go back, and there it is. And it updates again. To really test the persistence, right? What would you do? I would close the app and then restart it, because I could very easily make an app that lets me type stuff in and saves it on a list. But if I don't have a database backing that app, when that app gets closed, then all of that data is gone. That's part of the big reason about using a database. So to close an app on Android, you hit the little square down here, and then you slide it right off the top, right? And then you have to go find it again to open it back up. Where's my joke? There it is. My joke app boots up again, and if I scroll back over, you can see that the jokes still remain, right? They were stored in the database. Something that I'll probably show you, I only have 3 minutes left, so I can't show it to you right now, but you can actually navigate the files on the emulator on the phone and see where the database files are. You can't actually read the data very well. It's in a format that's not intended for humans, but you can actually see where the files are stored. And then the last thing is I can hit this clear button, and that's going to delete everything, and it just, my table is now empty. So that's about as simple as it gets for hooking up a database. As you can probably imagine, the next studio is going to ask you to walk through very similar steps for setting up a database on another simple app like this. And then we're going to have the next homework assignment come out on Thursday. And while I've got a couple minutes left, I think it's important to note that the app that I'm going to ask you to do next is going to ask you to use both a web API and a database in the same app. And so I want to make it clear that the architecture is prepared to handle this, right? You'll need to do all of the setup stuff for both of them, the web API library, retrofit, and the room library for the database. You'll have one repository file that will either access the web API stuff or the database stuff, depending on where the data that you need is coming from, right? And then the Viewmodel will access the repository. In fact, I think we'll talk about this a little bit more on Thursday when the assignment's posted. While you typically only have one repository per app, it is entirely possible, in fact even encouraged, to have multiple view models per app if I have multiple views within my app that are going to require the use of accessing either a web API or a database, some external data, right? And so that might be something that's worth considering on the next assignment as well. But that'll all be posted on Thursday. We'll have a chat about that in class on Thursday. Alrighty. Good luck with the rest of assignment 2. If you need help, we've got office hours tomorrow. I don't think we have any tonight. Do we have some tonight? Yeah, we have some tonight too. Right now, maybe. And tomorrow as well. So come in and get some help with that if you need to. Otherwise, I'll see you on Thursday. Have a good week.